War is changing, and it's not changing because of a new rifle or a faster jet. It's changing because of them. For decades, we joked about robots taking over, but right now, in labs across the world, machines are being built that don't just lift weights. They run, they react, and they adapt. The Pentagon is watching, China is investing billions, and the question isn't if these humanoids will enter the battlefield. The question is when. Today, we are breaking down the top 6 humanoids that are almost ready for war. We're talking about mobility that beats special forces, strength that shatters steel, and AI that never sleeps. So let's get into it. Starting at number 6, we have a robot that most people outside of defense and robotics circles have never heard of, but absolutely should know about. This is the Foundation Phantom Mark I, built by Foundation Robotics, and it's one of the clearest examples of a company that didn't build a robot for a tech demo or a trade show. They built it for the real world, and in robotics, those two are very different things. Most humanoid robots are developed in pristine lab environments, tested on smooth floors, and then fall apart the moment you take them outside. Foundation Robotics did the opposite. The Phantom Mark I was designed from day one to operate in unstructured, unpredictable, and genuinely hostile terrain. Gravel, rubble, mud. Steep inclines, narrow corridors. These are all the environments where human soldiers actually fight, and these are the environments that the Phantom Mark I was engineered to handle. Now, what makes the Phantom Mark I's mobility so impressive is the sophistication of its balance and shock absorption systems. Its leg joints are built to handle dynamic ground contact, meaning that the robot adjusts to what it's stepping on in real time, rather than relying on the ground being level and predictable. When a surface shifts under it, the Phantom Mark I compensates instantly. When it hits a step or a slope, it doesn't slow to a crawl or freeze, it keeps moving. And the gait on this robot is genuinely smooth. Not in a flashy backflip kind of way, but in a purposeful, deliberate way that screams operational reliability. It can navigate stairs, ramps, debris fields, and tight interior spaces. If you think about the environments where soldiers actually operate, those are exactly the spaces where wheeled and tracked vehicles simply cannot follow. The Phantom Mark I can. Now here's where things get interesting from a purely military standpoint. The Phantom Mark I can lift and carry serious weight over extended periods without any performance degradation. No sweating, no muscle fatigue, no need to put it down and rest. The robot's arms have multiple degrees of freedom, giving it the ability to not just carry a load like a dumb mule, but actually manipulate objects, operate equipment, and interact with the environment. Think about what that means in a military context. One of the biggest killers in combat isn't bullets, it's exhaustion. Soldiers carry 50, 60, sometimes 80 kilograms of gear through brutal terrain for hours, and by the time they reach the objective, they're physically degraded. A machine that can carry that weight indefinitely and arrive at the objective just as capable as when it left is not a small advantage, it's a massive one. Number 5 is a name you almost certainly already know, and if you don't, prepare to have your mind blown. Boston Dynamics Atlas is the most athletically capable humanoid robot ever built. Full stop. This machine has been doing things that shouldn't be physically possible for a robot since 2016, and with each new generation, it gets faster, stronger, more fluid, and more capable in ways that genuinely blur the line between mechanical system and something else entirely. What most people don't know about Boston Dynamics is that it has deep roots in military research. The company was originally funded largely through DARPA, the Defense Advanced Research Projects Agency, which exists specifically to develop technology for the United States military. Their earlier robots like Big Dog and Spot were literally built for battlefield logistics. Atlas carries that lineage into a dramatically more sophisticated package, and even though Boston Dynamics has since moved into commercial markets, the military relevance of what Atlas can do has never gone away. Everyone talks about the backflips, and yes, they are incredible, but the backflip is actually the least interesting thing about Atlas from a military perspective. The backflip is a demonstration of something far more important, which is the dynamic motion control. Atlas is not running a pre-recorded animation when it does the backflip. It's calculating physics in real time, adjusting its body position mid-air, and landing with controlled precision. That kind of real-time dynamic movement is extraordinarily difficult to achieve in robotics, and it's exactly what you need to know when you're operating in an environment that is chaotic, unpredictable, and constantly changing. The newest fully electric version of Atlas took everything the hydraulic version could do and made it quieter, more efficient, and even more agile. The electric actuators allow for a wider range of motion in the joints, which means Atlas can move in ways the older version physically couldn't. It runs, it jumps, it vaults over obstacles and recovers from stumbles and hits with a balance system so good that Boston Dynamics has literally had people kick it and shove it repeatedly in testing, just to see how it responds, and it always gets back up. The new Atlas also features a completely redesigned hand and arm system that gives it genuine manipulation capability. It can pick up heavy objects from awkward positions, carry loads while walking over uneven ground, and interact with tools and equipment in meaningful ways. Its torso and spine rotate with range of motion that allows it to work at ground level, reach overhead, twist around corners, and operate in cramped spaces without losing its footing. Here's the genuinely shocking part about Atlas though: its joints can exert forces and move at speeds that exceed what a human body can safely do. The machine is not constrained by the biological limits that define what a human soldier is capable of. It does not have a threshold beyond which its muscles tear or tingle and snap. Push it harder and it simply performs. Boston Dynamics has been publicly clear that they do not want their robots weaponized, and they have policies in places to prevent it. But let's separate intent from capability for a moment, because those are two completely different conversations. Atlas is, from a pure capability standpoint, the closest thing to a super soldier chassis that currently exists on planet Earth. It can sprint across rubble, clear obstacles, work in contaminated environments, operate without rest, and recover from physical impacts that would take a human out of the fight entirely. Whether the company wants it used for war or not, the technology itself is extraordinary, and the world's militaries know it. At number 4, we move to a company that has been quietly doing something the rest of the robotics world have been talking about for years but struggling to actually deliver: building genuinely capable humanoid robots at a price point that makes real-world deployment actually feasible. Unitree Robotics, based in China, has been disrupting the global robotics industry by taking capabilities that used to cost $500,000 or more and compressing them into platforms that are dramatically more accessible. The H1 and its upgraded version, the H1-2, are their full-size humanoid robots, and they are absolutely remarkable machines. Here's the number that stops people cold when they first hear it. The Unitree H1 has been clocked running at over 3.3 meters per second. That's nearly 12 kilometers per hour. For a bipedal robot, this is a world record speed, and it is not a slow, careful trot. It is a full, dynamic running motion where the robot is airborne between footfalls, just like human runners. The average person jogs at around 8 to 10 kilometers per hour, meaning that this machine is running at a pace that would make many humans work hard to keep up. Now, think about that in a military context. Speed in the field is everything. The ability to cross exposed ground quickly, to close distance, or create it to move from cover to cover faster than any adversary can reach. The H1 does that, and it doesn't get winded. The H1 stands at roughly 1.8 meters tall and weighs around 47 kilograms, which is impressively light for a robot of its capability level. Every kilogram of weight in a mobile platform is a kilogram of energy consumption and mechanical stress, so keeping the weight down while maintaining strength and speed is a genuine engineering achievement. Unitree achieved it by designing high-torque electric joints motors that are compact but powerful, and by using structural materials that are strong without being heavy. The H1 is not a fragile lab prototype. Unitree has tested it in fall recovery scenarios, rough terrain, and dynamic stress situation. When it falls, it gets back up. When it steps on something uneven, it adjusts. When it's pushed, it recovers its balance. That robustness is absolutely essential for any real-world deployment, and it's something a lot of impressive-looking robots fail at the moment you take them off the demo carpet. The H1-2 took everything the original A1 did well and added significantly improved arm systems. The arms now have a wider range of motion, greater payload capacity, and better manipulation capability at the end effectors, meaning the robot can now not just run fast but also carry and interact with objects in a meaningful way once it gets wherever it's going. The combination of speed and utility is exactly what transforms a mobile platform into something operationally relevant. The most important thing about the Unitree H1 series from a military perspective isn't any single capability, it's the combination of decent speed, real durability, meaningful payload capacity, and dramatically lower cost than the Western competitors. Military applications are not just about having one incredible robot, they're about having enough of them to actually change outcomes. Unitree's pricing model means that the H1 platform could theoretically be deployed in numbers that other platforms simply cannot match. And in warfare, numbers matter enormously. This is a platform the defense establishments around the world should be watching very carefully. Number 3 is also from Unitree, and this one is going to make your jaw drop. The Unitree G1 is a different animal from the H1. Where the H1 prioritizes full human scale and speed, the G1 is a smaller, more compact machine that Unitree built to do something very specific, which is move the way a human body at its most athletic actually moves. Not walking, not jogging, we're talking about martial arts level movement, and they absolutely nailed it. When Unitree released footage of the G1 performing kung fu sequences, the internet did not know what to do with it. The robot was executing spinning kicks, rapid direction pivots, low sweeping stances, and high-velocity multi-limb movements with a fluidity and speed that looked like it had been CGI'd. It hadn't been. This was real footage of a real robot executing real martial arts movement in real time, and it demonstrated something really profound. To perform these movements, the G1 needed to coordinate multiple joints simultaneously at high speed, maintaining perfect balance through the entire arc of a kick or a spin, and recover its center of gravity instantly when the motion ends. Each of those sub-problems is hard enough on its own. Doing all of them together at that speed with that kind of smooth precision is an achievement that puts the G1 in genuinely elite company in the humanoid robotics world. The G1 stands at approximately 1.27 meters tall and weighs around 35 kilograms. That smaller frame is actually a strategic advantage in many real-world scenarios. Narrow corridors, vehicle interiors, low clearance spaces, underground environments, dense urban terrain. These are places where a full-size humanoid might struggle, but the G1 fits comfortably. It doesn't sacrifice capability for that compact profile either. The power-to-weight ratio on the G1 is exceptional, and its joints deliver torque that allows for full squat depth, deep lunges, rapid lateral directional changes, and the kind of explosive movement that you'd associate with a trained athlete rather than a machine. The G1 is equipped with onboard sensors including depth cameras and LiDAR, feeding into motion planning systems that allow to perceive and respond to its environment in real time. It doesn't need a human operator guiding it every step. You can see an obstacle and route around it. It can identify a change in the terrain and adjust its gait accordingly. That level of environmental awareness is not optional for military applications. It is mandatory. A robot that freezes, falls, or requires constant teleoperation the moment something unexpected happens is a liability, not an asset. The G1 opens up tactical environments that larger humanoids cannot access. Urban warfare is increasingly fought in basements, tunnels, stairwells, and rubble-filled corridors, and a robot that can operate quickly and aggressively in those spaces has enormous value. Couple that physical capability with the G1's demonstrated agility and speed, and you have a platform that in a contested, close-quarters environment is genuinely difficult to stop. As weapons integration and autonomous targeting technology continues to advance, the G1's physical profile becomes increasingly significant. It is small, fast, agile, smart, and hard to catch. That is a very dangerous combination. At number 2, we have a machine that did not choose its name by accident. The EngineAI T800, named explicitly after the Terminator, is one of the most imposing humanoid robots to come out of China's rapidly accelerating robot industry, and it earns every bit of that intimidating branding. Where other robots on this list impress you with its speed or agility or intelligence, the T800 impresses you with something more primal, sheer physical presence and raw capability. EngineAI built the T800 for one primary purpose, and that purpose was performance in demanding real-world conditions. Not a lab, not a controlled demo floor, real conditions where things break, surfaces are unpredictable, loads are heavy, and the machine needs to keep working regardless. The T800 is a large and heavy-built humanoid, and that is a completely intentional decision. Its structural frame is designed to absorb impacts, handle stress loads repeatedly over time, and remain operational through the kind of physical punishment that would destroy a lighter, more delicate machine. The joints are built for endurance, not just peak performance. That distinction matters enormously in military context because battlefield equipment doesn't get gentle treatment. It gets dropped, knocked around, exposed to weather extremes, and pushed hard for hours at a time. One of the most interesting design choices EngineAI made with the T800 is building it with field maintainability in mind. This is something most people never think about when evaluating robots, but it is critically important for military application. A robot that breaks down and requires specialized facility to repair is essentially useless in a forward operating environment. The T800 was designed so that the damaged or worn components can be accessed and replaced under field conditions. That design philosophy is what separates a piece of impressive technology from an actual military tool. The T800's strength is where it really distinguishes itself. Its arm systems are built for high torque, heavy object tasks, and not just delicate manipulation. We're talking about a robot that can lift, push, and pull, and carry with a kind of force that goes well beyond what a human soldier can sustain. Ammunition crates, casualty evacuation equipment, breaching tools, heavy sensor systems, all of the gear that wears soldiers down over the course of the operation, the T800 handles it with ease. Many heavy-duty robots become clumsy and slow the moment you load them down. The T800 was specifically engineered to avoid that problem. Its locomotion system maintains stability and reasonable speed even when carrying substantial weight over uneven terrain. It handles inclines without tipping. It navigates debris without losing control. It keeps moving in conditions that would bring a lighter, less robust platform to a stop. The T800 represents a specific and extremely valuable type of military asset, a platform built for a sustained heavy-duty performance in harsh conditions. It is not the fastest robot on the list, and it is not the most intelligent, but it is possibly the most ruggedized, the most physically capable in terms of raw strength, and the most practically ready for the kind of physical demands that real military operations place on equipment. Its combination of strength, durability, payload capacity, and field maintainability puts it in a number 2 on this list without any question, and its autonomous systems continue to develop. It is only going to become more relevant. And here we are at number 1, the Figure 03 from EngineAI, and this one is in a completely different league from everything else on this list. Not because it is the strongest robot, not because it is the fastest, but because it combines serious physical capability with something that no other humanoid robot on this list can match. Genuine artificial intelligence, not the kind of AI that follows a decision tree or navigates pre-programmed obstacle courses. Real reasoning, real language understanding, and real autonomous decision making, all running inside a humanoid body that is built to human scale and capable of operating in the real world. This is one that should make governments, military planners, and anyone paying attention genuinely sit up straight. EngineAI partnered with OpenAI to integrate large language model capabilities directly into the Figure 03's operational architecture. What that means in practice is that you can walk up to this robot, tell it what you need in plain conversational language, and it will figure out how to do it. Not with a joystick, not by programming a waypoint sequence. You talk to it, it thinks, and then it acts. Figure has demonstrated this in real tests. The robot receives verbal instructions, reasons about its environment, identifies the relevant object and actions, and executes multi-step tasks autonomously. When something unexpected happens, it doesn't freeze and wait for human input. It adapts, it reassesses passes, it finds another way. That is not a minor upgrade over previous generations of robot. That is a fundamental leap in what a humanoid machine is capable of, and it has direct, enormous implications for military use. The Figure 03 stands at 1.7 meters tall, exactly human scale, and that is a deliberate choice that has profound practice importance. The entire world is built for human bodies. Vehicles are designed with human operators in mind. Doors, hallways, staircases, cockpits, weapon systems, communication equipment, all of it assumes a human proportion body. A robot that matches those proportions can use all of that infrastructure without modification. No custom interfaces, no redesigned equipment. The Figure 03 fits into a human world because it was built to the same dimensions. Its hands are one of the most technically impressive aspects of the whole machine. Figure AI has invested enormous engineering efforts into the hand system, and the result is a level of dexterity that approaches genuine human level of fine motor control. This robot can pick up small objects with precision, handle delicate equipment without breaking it, operate complex machinery, and perform tasks that require rear coordination between vision, thinking, and physical movement. The manipulation capability of the Figure 03 is not a gimmick demonstration for a trade show. It is a functional, operationally relevant capability. The Figure 03 is not going to win a sprint against the Unitree H1, but what it offers instead of top-end speed is something arguably more valuable for sustained military operations, which is consistent, reliable, long-duration performance. Its electric power management systems are designed for extended operational cycles. This robot can maintain steady performance for hours at a time, completing task after task without the degradation in quality or speed that fatigue would cause in a human operator. It also does not need any of the things that make human soldiers operationally expensive and logistically complex. No water, no food, no sleep, no psychological breaks after traumatic events, no rotation schedule. In a prolonged military operation, those factors compound enormously, and a platform that is immune to all of them represents a logistical and operational advantage that is genuinely difficult to overstate. Now here is something about the Figure 03 that most people don't know, and it's possibly the most important fact about this robot. It is not sitting in a lab, it is being deployed in real time and working environments. Figure AI has a partnership with BMW, one of the most demanding and precision-focused manufacturing environments in the world, and Figure 03 robots are working on BMW production lines right now. Every hour of that deployment generates real-world operational data that feeds back into the system and makes the robot smarter, more reliable, and more capable. That real-world feedback loop is something that purely military research programs almost never get, because classified defense robotics programs don't run continuous public deployments. Figure AI's commercial strategy is inadvertently creating one of the most comprehensive real-world training for humanoid robot operation in history, and the Figure 03 is getting better because of it at a pace that is genuinely alarming. Every other robot on this list requires meaningful human oversight to be operationally useful. A human somewhere is monitoring, directing, or at minimum supervising the machine's actions. The Figure 03 is moving rapidly towards something different, which is the ability to receive a mission objective and then plan, adapt, and execute that objective without constant human input. In military terms, that distinction is everything. A robot that needs a human controller for every decision is a force multiplier, but it's still fundamentally constrained by how many controllers you have and how fast they can process information. A robot that can be given a high-level mission and then go execute it autonomously is something else entirely. It is a force multiplier that scales, and the Figure 03's AI architecture is the closest any humanoid robot has ever come to making that a reality. Figure AI has not positioned the Figure 03 as a military product. They're focused on commercial and industrial deployment, and there are some genuine ethical debates in the robotics community about autonomous weapons that deserve serious consideration. But setting those debates aside for a moment and looking purely at capability, the Figure 03 is the most militarily significant humanoid robot ever built. It has the physical build to operate in military environments. It has the dexterity dexterity to handle weapons and equipment. It has the AI to understand objectives and adapt in real time. It has the endurance to outlast human operators, and it has a development deployment trajectory that is accelerating faster than anything else from this space. The current version is already remarkable. The version that it will exist in 3 years after 2 more generations of AI improvement and thousands of additional hours of real-world deployment data is something that should occupy the full attention of every defense establishment on the planet. Figure 03 is the number 1 on this list because it doesn't just represent the best humanoid robot available today. It represents the direction that military robotics is heading, and it is heading there faster than almost anyone expected. So there it is, 6 humanoid robots that are almost ready for war, and every single one of them is real, operational, and getting better every month. But let me ask you something. What do you think? When the machine is doing the killing, who exactly is responsible? The engineer who built it? The general who deployed it? The algorithm that pulled the trigger? And which one of these 6 humanoids concerns you the most? Tell me in the comments, and if you think autonomous warfare is a conversation the world needs to be having louder and faster than it currently is, share this video, because the machines already have a head start.